In the meantime, I'd like to introduce you to Toby Hede.
Hello, thank you. I'm out of time already, that's a shame. Obligatory Star Wars reference, thank you. I don't know why they picked March, what are we, May the 4th, when they could have gone with, Hoftober, Jar Jar Lai, March Vader, I don't know, there's so many other days that they could have done. I work for a company called Reckon. We make very boring accounting and business bookkeeping software. I'm going to talk today about serverless, which of course is, well, actually there are some servers, you'll see that later. There's actually not, this is kind of a nodeless talk also, because as it turns out when you're doing this stuff, it's all about AWS or your preferred platform of choice. I do AWS. So much AWS, you'll see it's a world of terror. Everything is terrible as a service is AWS's motto. But it's better than all the other services, and it's like a really crappy thing from the future. Like, it's like you can do this amazing stuff, just it's so not that good. Anyway, well, you're going to learn all about this. So I thought I'd start with a brief history of the cloud. So as we all know, computing began, roughly 1946 with a thing called ENIAC. Looks like this. This is DevOps, and this is, I think, a front-end developer. So that's good. Of course, nothing happened for about 60-odd years until in 2006, AWS invented the cloud. So that was amazing. And then you can see the rate of change in computing is really accelerating now. And 2014, a thing called Lambda was released by AWS, which is a large part of what I'm going to talk to you about today. The takeaway I want you to leave here with is I'm really convinced, as you can see from my fanboyism, that this is kind of a big deal. It's as big a deal as the original 2006 cloud kind of vision. It's a big step, in the way that we're going to approach computing, and a lot of what we're going to do in the future is going to be tied to thinking about stuff this way. More of that later. A brief history of web apps. So this is sort of the assumption. This is probably a large part of what you're working in. You've got a client, which is probably a web browser, an application, which would be Node in this case, or the lifts are there. It's talking to a database. This is a very simple architecture. What have I done? Yeah, well, actually, it's not that simple an architecture, because by the time we've deployed all of this stuff into our clouds, it's an incredibly complicated architecture. We've got a CDN here that's mapped to some sort of object store. We've got a load balancer, we've got some DNS, which no one knows how that works, so that's fine. We've got a bunch of auto-scaling instances that are they're tied to schedules or whatever. You've got a database with replication. So those very simple boxes become very complicated, even on a very, this is a vanilla Node.js app, basically. Like, by the time you're finished making it into production, it's a bit of a monster. So there are some things that we can do to make this easier. There's a whole bunch of different words for this stuff. Backend as a service, functions as a service, serverless itself. I thought I'd just clarify a few of these. So backend as a service, you may have used Parse or Firebase or some of these ones. It's basically a third party, often very mobile centric. Data storage is sort of the core of what they're doing. They might have some messaging or other kinds of things. So you tie your front end application to the back end as a service, and now your architecture looks a bit like this. So you've got rid of a whole bunch of stuff. You've got a single page, React or whatever we're doing this week, application talking to this third-party provider. Everything's cool. So now all you need to deploy is this. So you've got a CDN, some DNS, and a bunch of config, and you've made your life a lot easier. So that's kind of cool. Functions as a service is, I think, what most people would think of as serverless. And they are really event-driven, ephemeral, fully managed, stateless compute containers. So it's basically a bunch of managed Docker instances happening for you. The things that are really different about these, they're independently deployed, transparently provisioned, and build per request. The hidden thing underneath serverless, there was talk before that often the tech teams are not necessarily connected to the dollars. This is actually a very interesting big deal that I think, in the same way that the introduction of cloud computing changed the relationship that organizations had with technology and the speed they could engage with it, we're talking another step change of that kind of process. So one of my very first e-commerce projects, a long time ago, we were very proud. It was like the biggest budget we'd ever had. It was something like $80,000 for hardware. And it was essentially 2 web servers and a database server sitting somewhere in the late 90s. And that took 6 months or something to get across the line. Like the client signing off on multi-thousands of dollars. And nowadays, like one of the projects I'm on had something like 500 instances today. Just, they appeared and then they disappeared. like that's nuts. That's not even 20 years. The entire relationship of the business with computing as a resource has changed. This is what we're talking about with some of this stuff. So here's a hello world inside AWS. You see the build duration is 100 milliseconds. We're being totally ripped off. Hello world took 0.47 milliseconds. AWS, give me a refund. So this is, so a request to your endpoint, you build based on how much the duration was in 100 millisecond increments and the memory. It's crazy. So serverless is, I guess, a philosophy of all of this stuff all of the time. We don't want to manage anything. We want to make sure that all of the stuff possible is managed by someone else. If you have to think about operating system, you're doing it wrong. And it's a terrible term, but it's what we've got. So a question we often get is this microservices? And the answer is like, I don't know. Sure. You can do that, but it's not necessarily like the point of this stuff. So what can serverlessness do for you? So in AWS, it's now pretty much the canonical way that we glue stuff together. So this is an actual project we've got. At the moment, we've got, this deals with banks. So we've got a SFTP server that's over here in 2004. And then using patented time technology, it puts a file into an S3 bucket. Now, prior to Lambda, you would need some infrastructure that would be polling these changes, doing all of this kind of stuff. But there's just a function that is here that can decrypt that file that was being sent. It is triggered off an S3 event, so it only exists for as long as there's an S3. So a file comes in and it spins up. It can fan out to, this is, which one of the several events services? This is SNS, I think. So this is a message notification system. So here it's notifying, so an email can be sent and another function can do some processing. So this is the way that we now glue all of these different cloudy pieces together. You can also just look at it the way, just replace a server. And this looks just like, a more traditional infrastructure. So you've got, an API at the front. There's a bunch of things that do work, reacting to those. There's database in the background. It's much more the sort of client-server model that you would be used to. One of the other things that happens in any non-trivial architecture inside AWS, is you probably end up with both. So you've got Lambdas responding to requests. So this is reading something off the database to return to the user, just normal. But as things come in, you're not necessarily writing directly. You're feeding these events into all sorts of pieces of infrastructure, all of them offered at low prices by AWS. It's fantastic. But the interesting thing is, we're not creating any infrastructure to get this working. All of this stuff just happens. It is all, of course, complete lies. I've documented this for you in the example we just saw. Despite the name, despite the fancy stickers you can get and t-shirts, it's all servers. Like sometimes heaps of servers. Like a whole cloud of them. So people are often very disappointed when they just learn it is actually computers. But I feel I relate to that, because when I discovered it wasn't literally a cloud, very upset. It was just computers. I've got one. Use it every day. It's lame. Anyway, all right, let's try this. I'm going to show some stuff, if I can. So, there's a lot of moving pieces. This is Amazon's fantastic API. This is a project that was going to be released this weekend until this afternoon, so everyone's a bit upset about that, but that's fine. So one of the things, I'll start with Lambda itself. So this is the Lambda console. Inside here is, through the virtues of magic, this is pretty much a straight Node.js application. The IDE is amazing, as you can see. It's just a function that takes a particular set of parameters. You do a bunch of stuff. It's just, there's nothing that you haven't done heaps of times inside here. The format that you send back is slightly convoluted. That's kind of the vibe inside Amazon. Well, they keep changing their mind. So, there's a callback, you give it a response. In this case, it's a status code and a big blob of JSON, and that's cool. We handle an error. It's just normal, everyday JavaScript stuff. What is interesting about this is that Amazon is doing all the rest of the work. So you can actually go in and create a Lambda function in this console, and that is now transparently scaled and provisioned across multiple availability zones. It's about this. We've got a hello world, I think. We got 6.10. That was very exciting. Yeah. I think I counted we're like only 34 versions behind. Hello. Ninja. Yeah. There's a blob of code. You see that going on? Next. Exists. Yeah. This is the. Oh fuck. I don't know. Yeah. Here, have one I prepared earlier. It's probably granting this ridiculous permissions in some database, but anyway. Okay, let's test it. Yeah. Hello world. Sure. Bam. Look at that. So that was it. So that execution, it was 27.71 milliseconds. I'm going to be billed for 100. But that's it. That is literally now completely transparently scaled out on a Docker cluster. Amazon's doing all the rest of it. They detect the traffic that's coming through. We did we did quite a bit of load testing on the product we're at. We hit 1,000 requests a second. It was all fine. we didn't do anything. We just deployed this stuff. It's pretty crazy. Because everything is hard, if you want to actually get this stuff talking to the internet, so we've created a function that exists in this little environment. You need to map an API endpoint to it, which you can do through this. This is my favorite of all of the Amazon product experiences. You can go in here and you can map method paths, query. It's just amazing. So you're like, okay. So if you're working in AWS and you ever find yourself in front of one of their user experience centers, you really need to not do that. So the canonical way that we not do that in is this the right one? In AWS land is configuration. So we've swapped now. So we've got this function in the cloud from the future in this amazingly provisioned thing at milliseconds. But now we have to configure it. So this is a very simple project that has some functions in it. And we'll just scroll down here. That's a function. There's a function. There you go. Look at that. There's some code in a bucket. Yeah, keep going. What's this? Another function. All right. Go. Yep. I think it's it's amazing. Whew. There you go. 1,454 lines of JSON configuration, and you too can be living in the future. So that's cool. So the thing that I'm really selling to you is don't do that either. Or at least get your company to hire a DevOps silo to do that for you. I don't know. I might be doing DevOps wrong, but anyway. So there's a couple of frameworks. The one that I really like is called serverless, thusly. And it basically takes all of that complexity of running, of hardwiring all of this crazy config up, and it just makes it a set of declarations that you just add. There's still, they get a little bit more complicated as you go, but here's a read function. The source for that now lives in a project directory. So there's read, it's the one we were looking at before. You're not editing your code in that window, because that would be crazy. You can pass in environment variables. Here I'm doing the mapping of the gateway. So I'm saying, this is HTTP, the method is get, here's the path. It has API keys, usage plans, and all sorts of things baked in. So you can say private is true. You can add authorizers. You can do all of this kind of crazy stuff. You still need to, unfortunately, everything that you do ends up being YAML or JSON at some point. So this is a DynamoDB table, and so you're defining a table as part of this architecture. The thing that's really interesting about this is all of this config is now in my source control. Every developer can have their own mirror of this in the dev environment. The functions only cost while the developer is executing it. In our dev environment, I think when we were doing the really heavy load testing, the boss was like, our bill was $300 for the month for Lambda across 5 teams of about 5 people. It's kind of a ridiculous amount of how low cost some of this stuff actually is. But your entire architecture is now this immutable artifact, and it goes into your CI, and the tables are spun up, the functions are spun up, all the permissions for all of the infrastructure are there. And so it's like the first time for me at least that it's been this true, the developers own the stack, and the people on the team do everything. There's no downstream dependencies with this kind of architecture. So this, of course, presumes that you're using Dynamo, which is where you can just declare the database and it sort of appears in a very short period of time. RDS and some other things are slightly more complicated. What else can we show you? Any questions about serverless? There. Yep.
2 questions. Can you reuse database connections between Lambda and Cos?
Yes, you can. So we've got a lot of projects using Dynamo. We've got a couple using Aurora, which is the AWS fork of MySQL, essentially. It's just Node. So if your connection handling is not in the handler, but you're outside it, it gets executed on when it's invoked on the startup. And then your event, just like the pattern we saw before, where the connection pool was outside the express get. So it's exactly the same pattern. The only complexity we've seen is as it scales up, the connection pools might need tuning because you don't have each instance of the Lambda that scales behind the scene is going to have its own connection pool because it's scaling horizontally in a way that you might not have sort of anticipated. Because scaling horizontally, when you're running a whole server, like you really know that's happened. There's an auto scale group when you hit a certain line of traffic, but in Lambda it scales horizontally all the time. Like even for quite low volumes of traffic, it will bring new instances up so that your code isn't the bottleneck. So it just, but the short answer is yes. Yeah. You haven't?
Can Lambda listen straight to SQS?
No. So this is probably the most requested feature. So SQS is a simple queue service where you can queue things in, and the model for reading off the queue is one of polling, and Amazon have not done that yet. Lambda can queue, can read off the poll, but you have to schedule the Lambda execution yourself. So there's a scheduling mechanism built in. So say if you wanted a cron style thing that went in and cleaned out logs, or in this case SQS, you could have it turn on every second and queue, pull off the queue. That may not be fast enough for depending what you're using the queue for. We've got that in prod. Because we've got a non sort of real-time SQS, and that's fine for that, where it just pops off the queue. There's also Kinesis, which is an event stream. There's 3 or 4 different event models, and they're all slightly different, but yeah. Yeah?
For Lambdas, can you import any NPM module, and is that something you can do?
Yeah, so the question is, can you use any NPM module? Yes. There are some issues with things that depend on binaries, because underneath there's an actual instance. There are ways around that where you can put the binary, link the binary into your deployable code. There's people who are actually doing Go on Lambda based on that assumption. Go gives you a binary, and you can actually shim a Node.js thing to call shell out to a Go binary. It's they're completely desperate to use Go, which is fine. But guess what? You had to do JavaScript to get there. Suck it, Go guys. So there are some limitations. There's a bunch of stuff that are on the operating system. So things like image magic and a lot of the really common tools are actually thrown onto that instance. They pretty much, I've done graphics processing with Gmagic, most of the rest of the stuff just works. So that's about it, I think, for that bit. I get to skip everything went wrong, so that's fine. So people often sort of say, well, now you're locked into the cloud. Like, okay, that's true. So this is this is some code that is, talking to a product. This is the signature of the Lambda. And you're like, oh, well, let's get off Amazon. And you can convert it to an Express app. The core logic is actually exactly the same. At this level, all you're really worried about, this is the controller level, is just do a thing and return the right data for that thing. This is not where you're going to be locked in to your chosen cloud provider. The lock-in isn't at the code. This is the least of your problems. The lock-in is using their proprietary NoSQL technology, using their proprietary event stream, like Microsoft, Google, and Amazon all basically have a very similar feature set. That stuff is much harder. You've got gigabytes, terabytes of data that you would have to move out. Changing the function signature is like, we'll do that the day before it goes live, it'll be fine. So yeah, it's really interesting. People get a bit worried, like, I'm putting my node into this environment. A few caveats and warnings. This is still a little bit the bleeding edge there, which means, of course, you will get hurt. There's a lot of things about this execution model that you'll have to discover yourself. That took a lot of planning. That's the best part about that. So yeah, be careful. Don't use the Amazon user experience tools. Preferably use a tool, automate some stuff. Use a framework like serverless. There are a couple of others like Apex, a thing called Sparta, if you really wanted to go via JavaScript. If you're working at that level of JSON day in, day out, you're going to have a very sad time. Things can get complicated really quickly. You no longer have a server where a thing just gets executed. The technology pushes you into a proper microservice kind of mindset because there's no other way of doing this stuff in this technology, which is, it's a double-edged sword. One, like, you actually will do microservices. It handles some of the underlying complexity of how do we deploy all of these things. But you can have this explosion of other problems. Try not to over-engineer. So a lot of, you can see you've got events streaming into buckets, streaming into... This is how little paperclip springs are made. There's your SNS topic. You've got S3 buckets. And Amazon's constantly releasing new stuff, and you're like, my resume doesn't have that much for 2017. I really should add a couple of things there. I hear Kinesis is hot right now, or Athena. Ooh, Athena is actually legitimately awesome, but you can see it on my resume. But yeah, like, there's a real, and it's the grain of all of these providers is just add another service, low prices, which means you can sort of build yourself this really complicated architecture when actually a request hitting a database could well be enough. Like, you don't need to make it evented as well necessarily. Start small. That gives crashed the computer. And also, don't forget that you could actually just use a server because, like, we're not... I love this one too. Yeah. Pick a tool. Like, this stuff might be good for some corners of your product, like jumping all into a whole new platform could be overkill. So this is the future. I'm really convinced that this is the way that computing is going to happen. Of course, the future is currently in beta. But when EC2 first came out, it didn't have disk. It only had ephemeral storage, as in you spun up the instance, and when it died, and it could die randomly, and remember this is very early days, so they died randomly fairly frequently, there was no data. The data just disappeared. So we're still in that kind of era of this tech, where we haven't even worked out the problems that we have yet. But it's definitely worth looking at, and it makes a lot of things much easier, and you should check it out. The end. Yeah. Nice. Woo. Any other questions? Comments? Yes?
I was going to say, with AWS, is DDoS a problem, or will it make it go right?
So the short answer is yeah, it's a problem. They've got everyone is on something called Shield Junior. I don't know. So there's a base level of DDoS protection they do. There's throttling and things you can do for your endpoints. So there is some stuff they're doing. There's and you can pay low prices to get a higher level of DDoS protection. But yeah, like it's definitely something to look out for. The easiest way to do some of that is to set up monitoring and alerts, and it's a bit clunky. Yeah.
How do you debug stuff, and do you use stand-up?
Debugging. You haven't experienced the joy of debugging until you've tried it in the cloud. Hang on, I'll show you. So it's actually, this is the thing where it's really shitty. So I'll show you. Hang on. So you got CloudWatch, and then part of the other thing, like some of the cycles. So you can develop locally. But the other side effect of having this dependency on your large amounts of other products is getting end-to-end testing can be tricky. Each function though that you write it's purely evented. Like there's an event that comes in, you do some work and you output some stuff. So you can just do all of your normal test-driven development that you would be doing. I often will spend a whole day just in my test engine. It's just testing in and out. I don't even deploy because nothing's working for a start, so there's no point. But then, so you deploy once the tests have given you confidence that this is going to work. So that's the easiest thing to do, is actually you have to be possibly more diligent about testing than you can get away with in other areas. There's some things you can run DynamoDB locally. There's a version that Amazon provides, so there's some stuff you can do like that. This is your debugging tool of choice. It's called CloudWatch. This is what you get out of the box, I guess.
No auto suggestions?
No. Let's see. This is nothing. Hey, there we go. So this is your logs that go into this cloud thingy, and you can sort of see, you get requests, and these ones aren't logging too much stuff, and so you end up debugging in this. Like if you're debugging in the infrastructure, this is how it works. There's some other things you can do. You can get these logs out of this crappy tool and into Elasticsearch, other stuff. But it gets primitive really quickly. It's like console.log, deploy, console.log deploy. Like, just, it's really painful. Luckily, Amazon know this, and so at some extra charge to you, when it becomes available, there's a thing called X-ray coming, which is going to basically do end-to-end tracing through all of your Lambdas and events, and it will tie them all together, and it will let you graph and visualize this got called and this got called and this got called. So that's sort of in beta at the moment. Yeah, but it sucks. It's like the least good bit is trying to work out what is going on. Yes?
Every time a kind of request one of your functions come in, does it have to load like your imports at the top of the file every single time? Or? No,
so it does a bunch of smart stuff. So it will, it's basically Docker. Yeah. And so it'll be a Docker container with a node process running already. And so that initial startup cost, you can sort of put into that booting the app if you...
It kind of has like sort of memory, but not really.
Yeah, so it's just a node process on an instance with some memory attached to it. So it just internally is just node. So if you put stuff outside of the handler, it exists for the life of that node process. So there is, you aren't in charge of the scheduling. So there is, sometimes you will get caught where it's actually spinning up a container, and so you'll see your request latency jump out to like 2,000, 3,000 milliseconds. Bunch of dirty hacks that you can get to get around that, and it's probably the biggest problem we've run into with some of our user-facing requests, because under the covers then they'll shut it down. A bit like Heroku. Does anyone remember Heroku back in the day, where on the free plan they would turn it off, and so then the requests would come in and it would suddenly take long. It's faster than, well, I was doing Rails at the time, so it would take like a couple of minutes. But so there are some. This is what I mean by bleeding edge. Like there's stuff like this which you discover through seeing your the complexity of your app. But one of that project, which is the SFTP, that was sitting on a couple of instances. I think they worked out they were small. It's like $70 a month for an auto-scaling group of instances to pull from the SFTP, and it went to 7 cents a month. So that's the kind of, because the infrastructure is not there anymore. At midnight, the function gets scheduled, and it comes alive, and if there's a file, it grabs it.
Is there a concept of like restarting the thing?
They restarted transparently. Like their lifetime of an actual Lambda container is 15 minutes.
If you like push new code in to restart?
No, it does all of that stuff for you. Okay. And it does it. It's very. There's a lot of smarts under here. This is why it's from the future. Is they do stuff like they will retry things for you. You don't need to do the retries on the message queue, because they are triggering the events into your Lambda, and if a Lambda doesn't handle it, they will do it again, and they will automatically back off, and they will spin up more instances and try it again. And none of that, all you did was just go, hey, take my code, do whatever you want. So some of that stuff with the eventing and like with Kinesis is an event stream, and again it's a poll kind of mechanism, and they just handle that. So it's streaming off multiple shards of events, and all you do is go read the stream, and it spins up the number of instances that you need to get the throughput of the data. And so there's stuff like that that's underneath, that's the big trade-off. Yeah, okay, it's 1,500 lines of JSON and life is terrible, but it's got an exponential back-off retry mechanism on the message queue, and I don't even know what those words mean. I just npm installed a thing. It's fantastic. But there's some sharp points that you will discover. Yes?
Have you tried using Microsoft Azure functions or the Google Cloud one, like comparison?
We did a little bit with the Google Cloud functions. Azure, most of the people that work are .NET people, so everyone loves Azure. Yeah, they've done a little bit of work with that. The Google stuff is only just hit general availability. Pretty much any platform you go to will have an equivalent product or service. If you really want to do it yourself and you're excited about running a Kubernetes cluster, there's a couple of open source projects that will bring this kind of vision of infrastructure to Kubernetes. If your workloads don't fit inside Lambda, what have I got? Let me sell you on this project that I made, so it's awesome, called Containerless. This will just, using the serverless YAML, will pump a Docker image into an ECS cluster. And so this is all, you just need to tell it what VPC and Docker repository you're running in. And behind the scenes, it will build a Docker image, deploy it to ECS, mount it into a load balancer, do all of this kind of stuff. So there are other things as well, but some of it is just like cloud. It's a conceptual thing of like, actually, I just want a function to run. I don't care about the infrastructure. So that they're all equally awesome and terrible.
There can be many interdependent services in AWS. So is there any way we can do integration testing or end-to-end testing except debugging and doing testing the individual functions?
So what we do, so we've got this tied up into CI, and of course this whole project is the config for the project is inside the project, if you like. It goes into the CI build. It spins up, it runs the tests locally first, like in CI. If they pass, it deploys a complete new stack. It then runs the integration suite against that stack, and then it tears it back down. And so the functions, so our biggest project is something like 80 functions across a dozen services. And the integration environment is completely ephemeral. Like it exists, we run the tests, and we shut it back down. And that to me is where the real power of this starts coming into play. You've got your entire architecture just there. You can execute it. You can do whatever. It's quite cool. Awesome. Thank you. Cheers.